to make sure that we get comfortably at the grade 6 on this paper, at average sort of thing. So that's this question here. I made it kind of big because this is tricky. If there's like all these, the little squares make my eyes go like, whoa. And then maybe also on the recording, if anyone's watching then later, it could not look as good. Or even generally maybe on the screen share. So I tried to make it much bigger. Question 11. So first of all, we can clearly see that some sort of statistic. So the second statistic question in this first main bit we were doing so far. And we have a box plot here, right? It says even here, look, it says box plot, or it says twice, box plot. So we know what the topic is. So definitely refreshing box plot, good idea. Again, I think this is not necessarily that difficult topic, so that's why I just went for this question as like the one that tips us comfortably to grade 6. Okay, right, so Alice recorded the number of cars going into a village on each of 80 days. Good. So something is happening here over 80 days, different amount of cars. Oh, there we go, right? On each day, you see different amount of numbers. For example, on one day, you only saw 300 cars. Really? That's a lot of cars in a village. Fair enough. It's a big village. The incomplete table and incomplete box plot gives some information. So again, just to read out of it. So it's about how to understand the tables and like how to basically gather data and represent data, right? So on one of those days that were the as few cars as possible was there were only 300 cars, and one of the craziest busiest day there was we don't know, it ranged 1,000. So whatever that is, somewhere here would be that one day, maybe if it goes up to 1,400, say that's she saw 1,400 cars on that day, right, and recorded those. So that's what it means. Right, so use the information in the table to complete the box plot, right? So list number, I'll use a different color so we see what I did and what was there before. 300 is here at the end of the whisker, and so then we can put the whisker there, right? So that's my 300. I'll just make a note of the numbers that I want to see, right? So that lower quartile we can actually read from here. So if this is 6, therefore this is 7, 8. So every small little square, right, would be 20, because that would be 20, 40, 60, 80. So I put just 700 here, and therefore 80, right? So 780 is the lower quartile. Now, median 900, so that's here. So I'm going bit by bit, either write it in a box plot or in that table. Upper quartile, well, I'll read that from there. That's 1,200. And if the range is 1,000, I'll go from 300, add 1,000, and I'll end up at 1,300. There we go. So the maximum on one really busy day, she saw 1,300 cars in that village. All right. So, or recorded. I don't know if maybe she saw more and only recorded specific ones, but yeah, so let's use the specific language. So use the information in the table to complete the box plot we did and the table we did. Great, done without even properly reading what I'm supposed to do, right? So this is just working with the box plots and tables. Now, on some of those 80 days, Alice saw fewer than 1,200 cars going into the village. Fewer than 1,200, that's here. Fewer than 1,200, anywhere this way. Work out an estimate for the number of days Alice saw fewer than 1,200 cars going into the village. This is actually a really easy question. Again, if you know and understand box plots. So box plots is definitely a topic that is worth knowing because it's not really difficult. It's just to have some information. And the idea is that this, between the minimum and the first quartile, is 25% of all those days, in that case, when we are then recording various numbers of cars on the village. And between the lower quartile and the median, there's another 25%. And between the median and the upper quartiles is another 25%. And this is the last 25%. So this whole thing here accounts for there 75% of all those days. So estimate for the and it's estimate because it's not this all is not really telling us this is for sure, but basically a number of days Alice saw fewer than 1,200 cars, so that would be 75% of 80 days, right? So quickly checking my, yeah, that's good. And also I didn't check the previous, I should probably, yes, 400, yeah, we're good. So 75% of 80, 3/4 of 80, right? And 1/4 of 80 is 20. So 3/4 will be 60. Done quickly, easily, without having to do anything. Otherwise, it's 0.75 times 80, and that gives me the 60. However you want to work this out, but I'm just thinking this is 3/4, and it's easy to find a 1/4, and from there go to 3/4, which is in a way also kind of a little bit like working with ratios. So the ratios are strongly included in a lot of questions here, right? In a way, the working with fractions like that uses the ratio proportion kind of expansion reduction idea. Anyway, just saying. So 60 days. Did we have any? They just put 60 as an answer. So I probably didn't copy. There will be like dot 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 days. But yeah, that's it. I can underline this so it's visible. That's our final answer. What if we do this? Would it give us on this paper comfortably to grade 6?